Right. So I have now no output sound, but it's okay. But also, like this massive ease of for us to deploy models also has led to an even broader search of a unicorn data scientist. So for the past few years, we've seen that data scientists need to know about data visualization, software engineering, analytical skills, programming, and some data engineering. But now also for us to take things in production or into our customers, we also need to know about containerization, end-to-end machine learning, CI, CD, versioning, deep learning, NLP, privacy and security, distributed compute. So it is a lot of tasks to take for just one single person or one single role within a team to develop. And I'm going to now introduce MLOps and how these practices or this help with this problem. So companies are still looking for a unicorn. There's still this search for this elusive unicorn, but we're starting to see that, well, that doesn't exist, so we have to start making compromises. Companies will have to start making compromises. So, well, we have to cap at a certain point where what skills we're demanding. We're entering a certain, like, same phase to when the origin of DevOps started. DevOps really started because there was a conflicting or like opposite requirements between software developers and operation teams. Back in the day, software developers needed to move and iterate fast, being able to deploy software faster, test it as soon as possible. Whereas the operation teams that are the folks that are in charge of keeping the servers all the time are much more concerned about stability, availability, and those are their priorities. So if you think about this, it all seems to be at the day opposite goals and opposite objectives. And that's how DevOps actually started. And whenever I talk about it, I like going to this definition by Donovan Brown, where he says that DevOps is the union of people, processes, and products to enable continued delivery of value into production. And I think value is the key word here. And for us to be able to develop this, provide this value to our customers and software engineers, we revolve around three main principles, which is automation, feedback, and no manual handoff. So automate as much as you can. Identify early on what can be automated and what should be automated. Because we rely on fast iteration, get immediate feedback. As soon as there are changes on the code, there are changes on the data, there are changes on the model, we want to test immediately. And also avoid manual hands-off. It's very, very hard to do a fully iterative cycle, because when you have to push your model and then you have to wait for someone else to click deploy or to click a button or actually do the manual deployment or building or testing. So if we have automation and feedback score a priority, then we ensure that there are no manual hands-off, so there are not going to be walls and there are not going to be problems to provide early testing opportunities to all of our team members. So when we apply these principles to software engineering, this is how it normally moves. When you develop, well, you're developing code, or you push any code changes to whatever your version control system is, could be Git or Mercurial, and you can then be using GitHub or GitLab or whatever. Those changes link directly to your automated build and deploy or whatever, but you are allowed or you are enabled to get immediate feedback. So normally in more traditional software engineering, you'll have your small tests, unit tests, regression tests, and you can see easily which tests are passing and which ones are failing. And then you can carry on iterating. Depending on which tests are passing or failing. So you have little lag time between developing and testing and probably releasing. But also necessarily apply one-to-one to machine learning because there are a lot of additional technical considerations that we didn't have with traditional software engineering. When it comes to machine learning, we have a higher reliance on metrics. So that traditional cycle of having tests and seeing what tests pass and what tests don't is not enough. Because sometimes we need to look at things like accuracy, specific, losses. And we are also very, very guided by data visualization. Sometimes we need to create heat maps or truth tables. So and for us to make sense of the metrics, the database, and the model outputs as themselves, we also need to have certain domain knowledge. We need to have an understanding of what actually we're expecting to happen and how our metrics are related to the model or the code that we're developing. But so far, I've said I focused a lot on machine learning code. I said we develop our code, we develop our model, we push. But actually, working in machine learning and data science goes way beyond just creating model, just creating a model. So we have to think about the whole picture. It is configure your pipeline, collect your data, do data verification, analyze your code, monitor your models or your application. And because of all of these confounding factors, now we're seeing a very similar trend where data scientists and SREs or machine learning engineers seem to have, again, these opposing interests or these opposing goals. Again, the data scientists need to move very, very fast. We have frameworks that are very helpful and we already love. For example, Tensorflow, or Keras, or scikit-learn, or if you're using R, you ideally want to carry on using all of those frameworks instead of having to move onto an end-to-end managed machine learning pipeline or machine learning platform. As a small weight between different stages of our pipeline, whereas our fellows machine learning engineers usually want to reuse the tooling and platforms because otherwise, if you have complete separate tooling and platforms for engineering and machine learning, it becomes really, really hard to maintain and keep track of everything. There are also monitoring, reliability and stability, and also compliance of your data and your data-related applications. So we don't need to adapt, or refactor this continuous integration cycle. We're not only looking at code, we're also looking at how our data is changing. Are we collecting more data or are we doing transformations? And also should be constrained about data lineage. Things that can be automated is not the building only and deploying and tests. But we can automate parts of our pipeline like training, data processing. And our feedback will not come from past or not past tests, but also the SOT metrics. And then aggregating these parts of our pipelines means that we can iterate and improve our model based on our outputs or outcomes. So how do we get started? very often when I tell people about MLOps and automating their machine learning pipelines and processes, a lot of people say, I don't work at Microsoft, for example, so I don't have all the 500 software engineers at my disposal. And you don't need to build an entire new platform from scratch. You can recycle the ecosystem that you're currently using. If you're working in data scientists and software engineers, more than likely you're going to already have a version control system. Whether it's Git or Mercurial, and you're probably going to be using an open source development platform, continuous integration, and continuous delivery platform. This can be GitHub with GitHub Actions, GitLab with GitLab CI, Travis, or any other combination. So you don't need to migrate to anything else. You can leverage what you're currently using to collaborate. You can leverage also in those platforms that you're already using for your deployment and for your infrastructure management. So you can carry on using Travis, GitHub Actions, or AIOps, for example, or Make. Yes. And you can mix and match. One of the nice things of being able to leverage this ecosystem that you is that you can keep not only your platforms, but also the frameworks that you and your data scientists are familiar with. And if needed, you can leverage also cloud computing. There are a lot of things that you can actually do from, for example, GitHub Actions. I'm going to provide some examples with this, where you can actually instantiate a virtual machine with GPUs enabled and do your training there without you having to manually do all of this. So how do we start? We already have these two people in our team, for example, data scientists and SRE or machine learning engineers. And machine learning or data scientist folks will have their own environment where they're developing, iterating, doing research and development, and optimizing their models. And their SRE or machine learning engineers will have their own systems as well. But what we share, or what you will share basically, is this software development platform. I'm using GitHub as an example. And probably you want to use the distributed cloud or something else to do the staging and the serving or the production deployment of your products, whatever that is. It can also be a local stuff if you're working on more research stuff and you're using your local servers. And then we also have the data realm. We have the area where we're much more concerned of data, but that belongs a bit more towards data scientists and data engineers. So to get started with MLOps, as a traditional cycle, the data scientists will be working on their code. It can be a model, it can be an app, it can be whatever they're doing, and they check in their code into version control, let's say GitHub. So because we're talking about data science, you're not normally only checking in your code, but also your data. And something that I really is DBC, because it allows me not only to keep track of my code in conjunction with GitHub, but I can leverage the same Git flow and the same workflow that I've been using to also keep track of my hyperparameters, my model versions, additional parameters, and data versions, especially if these are coupled with cloud solutions to store my data. For example, if you're using AWS or Azure or GCP, it can integrate very nicely. So this is what data scientists will normally have in version control. If there are changes, once those changes are actually made and pushed into my version control system, it will immediately kick off this CI or CD pipeline. And this is going to be fundamentally different from the pipelines that engineers or SREs use. Because I'm using GitHub as an example, I'm going to be referring to GitHub Actions, which is the platform that now they have for CI/CD and automation. And one of the advantages is that you get already compute. So you're using a short compute on the background, and it actually gives you quite a good amount of it. So you can start doing a lot of interesting things. But also, and this is an example that I've done using. You probably want to use GPUs for your training. A good thing is that you or I've done in the past is spin up my virtual machines with GPUs so I can pick up the training and then decommission that virtual machine. But again, as I said before, the CI/CD for machine learning is not necessarily perform just the tests and build a package or a product. But we can also do a training run on whatever data or whatever process data that I've already collected. So this is an example on how you would, for example, use GitHub Actions to do that. I normally use even the latest, but it makes sense to check out the repository, set up whatever Python version you're using. If you need to make sure that your framework or your library and your model can be used across different Python versions, you can do that. But also, if you're focusing on the training, only you can execute your training on your compute. There, depending. By default, GitHub Actions only give you CPUs, no GPUs. But as I said, there are different workarounds. And once this is completed, you will get a set of logs with the information, with the commits that you've triggered that step in your pipeline and how long it took to actually process. But what happens if after you've done your training, you probably need to update your parameters, or you need to have a baseline model to compare against? Well, there is no problem, because if you can separately also have, for example, a YAML file with the parameters that you're passing. In this case, these are parameters for a VGG19 style transfer model on Keras and Tensorflow. So I can easily update the YAML file where I'm passing those parameters and get information. Actually, DVC is working on a product called Continuous Machine Learning, which allows you to combine GitHub Actions with the ability to add reports and metrics to your pull requests. So you can actually see the change not only in your code, but as you're doing your training, you can see the deltas or the lambdas between your metrics as well, get information on the GPU compute that you're using or CPU compute that you're using, and also keep track of the different training parameters that you have been testing. You can also imagine having automated, if you're creating a pull request, probably see how your accuracy or any other metrics are improving or getting worse as you are tuning your parameters. So this is very, very helpful, because you have this established Git workflow or Git flow, and you're adding an additional layer for machine learning on top of it. And this allows to make a seamless handoff directly to your SREs or machine learning engineers. Is once you've done the optimization, you've made sure that everything is working, you're leveraging the same platform that you both teams share, actually. So the handoff is automatic directly to the SRE, or they can trigger the CI and CD pipeline one last time to do whatever test they need to do, make sure that everything is compliant, make sure that monitoring is in place, and roll out seamlessly to the world. And this is very, very exciting because that means that you don't have to change any of the frameworks or any of the platforms that you're already using. But these examples that I show are just a tiny of what you can do with MLOps. If you go now to the Jupyter organization in GitHub, you're going to see this repo.docker GitHub action, where it allows you to, if you've been using different notebooks and Binder, for example, to share your tutorials or your work with colleagues or the work, you probably know that building the Docker image can take a very long time. But what about if you could actually get a link to a Binder every time you create a pull request or updated a pull request, or you could cache the creation of the Docker image and then optimize the sharing of their machine learning solutions. So this action allows you to do this. This is an example using, for example, Azure machine learning, where everything, all the provisioning of the workspace, the compute, deployment, creating the training run, registering model, and deploy model has been automated and done through GitHub Actions. So once this is in place, the only thing to worry about was updating my model or my parameters, and this end-to-end scenario was built up for me. So I didn't have to worry. The colleagues I was working with didn't have to worry about having access to my machine learning workspace or my resources, because they could see all the logs directly from GitHub Actions. And also from Hamel Hussein from GitHub, he's been working a lot on machine learning actions and machine learning operations, with a different version on using chat-ops or using commands through pull request comment. And it allows him to also submit the jobs and get model evaluation results. So interesting, because you can then mix this with automation workflows, for example, to auto-label issues, assign reviews, merge requests, and it makes the whole workflow more seamless. So in brief, machine learning ops or DevOps for data science allows you to be more efficient with the tools you use and love already, as well as recycling your ecosystem. You don't, again, as I said, you don't need to move to a fully managed platform. You can leverage all of the existing platforms and toolings that you're already using, and find a way to create a seamless workflow. So this is where all the slides are going to be after the talk. They should be up in about 10 minutes or so at most. And if you want to reach out at any time, this is where you can find me. In the coming weeks, I'm going to be working of tutorials and blogs on how to use MLOps with GitHub Actions for GitLab and Tensorflow, and so folks can actually get started with different ways of deploying virtual machines from zero to something that they can then later use and scale. I think I have some time for questions. I apologize for the issue with the echo before, but I think in the end.